Today I will start SN1 and SN2 mechanism. SN1 and SN2 mechanism. Very important. SN1 and SN2 mechanism. Very important for both JEE Mains, NEET and board. First one is SN1. Substitution nucleophilic unimolecular. One means unimolecular. Substitution nucleophilic unimolecular. First one. Second one is substitution nucleophilic, that too means bimolecular. First one, substitution nucleophilic unimolecular. Second one, substitution nucleophilic bimolecular. First, we learn about what is the nucleophile and electrophile. This is the first part of the part. What is the nucleophile and electrophile? That means positively charged, like NO2 plus, Br plus, positively charged species act as a electrophile. Positively charged species as an electrophile. Positively charged species as a electrophile. Any positively charged, just like X plus means halonium ion, NO2 plus, okay, carbocation CH3 plus, carbocation CH3 plus. Any positively charged species act as the electrophile. And also nucleophile, that means water, that means OH minus, that means CN minus. CN minus is specialized star marked part, that is the ambident nucleophile. That is the specifically, these two is the very important topics. NO2 minus and CN minus, that is an ambident nucleophile, like water, OH minus, any negatively charged species which can act as an nucleophile. Which one act as a nucleophile? First, I will discuss the electrophile. Electrophile means positively charged species act as an electrophile and negatively charged species act as an nucleophile. In that case, CN minus and NO2 minus, this is the most important part, that is an ambident nucleophile. When I will start from that part, write down the group nucleophilicity increases. Down the group nucleophilicity increases. F minus less than Cl minus, less than Br minus, less than I minus. One thing, this is the big question for nucleophilicity order. This is the big question for nucleophilicity order. If you can take this angle Ri, get a Ri, Rbr, Rcl and Rf. One thing remember it, Rf, that means alkyl iodide, that means alkyl bromide, that means alkyl chloride, that means alkyl fluoride. If I will take these four types of alkyl halide, one thing remember, star mark, one thing remember, that is good nucleophile Good nucleophile is a good living group. Good nucleophile is a good living group. So nucleophilicity order and living group ability order in the same I minus greater than Br minus greater than Cl minus greater than F minus. That is the living group ability or nucleophilicity order is the very, very important question. But one thing, basicity order is reverse one. Basicity order is reverse one. This is the F minus greater than Cl minus greater than Br minus and greater than I minus. This order is the basicity order. Very, very important part. This is the basicity order. This is the basicity order. Basicity order. Is the big two question is given to you. One is the basicity order halide ion F minus greater than Cl minus greater than Br minus greater than I minus. And one thing remember, if there is an nucleophilicity order and living group order I minus greater than Br minus greater than Cl minus greater than F minus. Hear it? Another thing is across a period nucleophilicity decreases. Across a period, if you take the periodic table, across a period nucleophilicity decreases. Nucleophilicity decreases, then CH3 minus greater than NH2 minus greater than OH minus greater than F minus. That is the this is the technical part of the MCQ. This is the nucleophilicity order across a period. Across a period. One thing remember, this is the special technique. Star mark. Then another star mark. Bulky group, bulky base, bulky group is which much more higher molecular weight. Bulky group or bulky base is less nucleophilic character. Bulky group or bulky base is a less nucleophilic character. This one less than CH3, CH2, O minus. This is the bulky group. This bulky group is less nucleophilic character than non-bulky group. This one is the much more bulky group. This is the tertiary group and this is the purely ethyl group. So this one is the bulky group. Bulky group is less nucleophile than normal. Then I will start from the SN1 and SN2 reaction, and also I will discuss type of reagent. Type of reagent. Type of reagent. One thing remember, protic solvent. Protic, that's it also important. Protic solvent. Protic solvent. Protic solvent. One thing you may remember, protic solvent. Just for example, protic solvent, just for example, water, acid, any type of alcohol, that is an protic solvent. That is an protic solvent. And another is aprotic solvent. aprotic solvent. These are the big topics. Aprotic solvent. That is an aprotic solvent. Aprotic solvent, there is also the part just like DMF, DMF, DMSO, DMF, DMSO, acetone, in these three, polar aprotic solvent, polar aprotic solvent, polar aprotic solvent. So what do you mean DMF? DMF means dimethyl formamide. This is the formamide. This is the formamide, and this is the dimethyl formamide, and this is the dimethyl formamide. This is the dimethyl formamide that is known as DMF. DMSO, that is means dimethyl sulfoxide. I will take the structure. Dimethyl sulfoxide, CH3 whole 2SO, that is dimethyl sulfoxide. And another is non-polar solvent, non-polar solvent. Another is non-polar solvent. Another is non-polar solvent like benzene, hexane, cyclohexane, there is then classification of the part. There is then classification of the part. Next, I will just start the SN1 mechanism. SN1 mechanism. Remember it. SN1. There is an alkyl halide. Okay? There is an alkyl halide. And aqueous KOH. In aqueous KOH, OH minus act as a nucleophile. ROH plus KX. This is the nucleophile. In SN1 reaction, there is then two steps. First step, formation of carbocation. First step, formation of carbocation. There is 3 degree, greater than 2 degree, greater than 1 degree. First step is the formation of carbocation, and second step is the attachment of nucleophile. Second step is the attachment of nucleophile. First step is the formation of carbocation, and in that case, first step is the slowest step and rate determining step. First step is the slowest step and rate determining step. This step depends on stability of carbocation. 3 degree greater than 2 degree greater than 1 degree, and second step, this is the attachment of nucleophile. In that case, I will take the example. Reactivity order of alkyl halide. Reactivity order of alkyl halide. Ri greater than RBr, greater than RCl, greater than RF, There is the reactivity of alkyl halide. That is the one reactivity of alkyl halide. That is the another reactivity of alkyl halide. There is CH3 whole 3CX greater than CH3 whole 2 CHX greater than CH3 CH2X greater than CH3X. That means 3-degree alkyl halide greater than 2-degree alkyl halide greater than 1-degree alkyl halide, and this is the methyl halide. Done it? This is both for the SN1 mechanism. This is both for the SN1 mechanism. And SN1 mechanism that depends on stability of carbocation 3-degree greater than 2-degree greater than 1-degree greater than methyl. And also you will write down resonance stabilized carbocation. Resonance stabilized carbocation, and another star mark, rearrangement also occur. This is the special case for SN1 mechanism. Rearrangement reaction and also resonance stabilized carbocation preferable for SN1 mechanism. Okay, I will take the example. First one, I will give various examples. First one, that is tertiary butyl bromide. Okay, that is tertiary butyl bromide. It will take aqueous KOH. Okay, first this is OH minus. This is the nucleophile. This is OH minus. This is the nucleophile. First step, here is the leaving group. It will take CH3, C, CH3, CH3 plus. That is the 3-degree carbocation. Most stable carbocation. That is the 3-degree carbocation. That is the most stable carbocation. That is the first step. And second step, OH minus nucleophile, which can attack this one, and it will get that CH3, tertiary tart butyl alcohol, and that is then 3-degree alcohol. So first step, that is the first example for SN1 mechanism. First step, here is the leaving group. After that, it will produce 3-degree carbocation. Then second step, nucleophile attack that carbocation. It will produce that 3-degree alcohol, tart butyl alcohol. One thing remember, dx by dt, that means rate of reaction. reaction. That means rate of reaction. dx by dt is directly proportional to concentration of alkyl halide. This part also I will discuss when in case of chemical kinetics. And so dx by dt equal to K into concentration of alkyl halide. This K is the rate constant. This K is the rate constant. This K is the rate constant, and that is the first order chemical kinetics. That is very important question also for JEE and WBJEE, any competitive examination. Then SN1 reaction, that is the first order chemical kinetics. SN1 reaction, that is the first order chemical kinetics. dx by dt, rate of reaction, is directly proportional to only the concentration of alkyl halide. In that case also, write down polar solvent always increases the SN1 reaction. Polar solvent always increases the SN1 reaction, like water, like alcohol, like ammonia. In that case, water bracket a hydrolysis. Hydrolysis. In alcohol, that is alcoholysis. And in ammonia, bracket a ammonolysis. In case of, that is a purely polar solvent. One thing remember it, polar solvent is always increases the SN1 mechanism, like water, like alcohol, like ammonia. In case of water, hydrolysis. In case of alcohol, alcoholysis. In case of ammonia, ammonolysis. That is favorable for the SN1 mechanism. In that case also, I will take another example. This is I will take different classification of example. Aqueous cabbage. In that case, aqueous cabbage, same thing. That is vinyl bromide. That is vinyl bromide. That is vinyl bromide. That is bromobenzene. And also CH2 double bonded CH2 Br. That is allyl bromide. Allyl bromide. That is also same reagent, aqueous KOH. Identify the main product of the following reaction. Identify the main product of the following reaction. First one, in case of, first I will discuss the SN1, after that I will take the SN2 reaction. First of all, in that case, SN1 reaction is favorable mainly for 3 degree, greater than 2 degree, greater than 1 degree, 3 degree and 2 degree, most of all preferable for SN1 mechanism. But resonance stabilization is also favorable for SN1 mechanism and rearrangement reaction also. I will this is the no reaction and this is the no reaction. How can you explain these two reaction? That is a no reaction. No reaction. No reaction. This is the no reaction. This is the no reaction. And this reaction is favorable for SN1. This reaction is favorable for SN1. How can we explain? First of all, bromobenzene. First of all, bromobenzene. This is the bromobenzene. Okay. When it will take the leaving group, and that is the phenyl carbocation. That is K, phenyl carbocation. Phenyl carbocation. Unstable carbocation. Unstable carbocation. For this reason, any nucleophile which can directly attach this type of carbocation, unstable carbocation. For this reason, any type of nucleophile which can attack this type of carbocation. Done. First one is the no reaction. That means bromobenzene reacts with aqueous KVH. There is no formation of phenol. Some drastic condition, it will take that phenol. That means any aryl halide cannot attack directly nucleophilic substitution reaction. Next one. This one is phenyl bromide. That is phenyl carbocation. That is K, phenyl carbocation. That is also non-existence of carbocation. That is also non-existence of carbocation. For this reason, if we take this one, that is also no reaction. So first two reaction is not possible. First two reaction is not possible due to non-existence of carbocation. First two reaction is not possible due to non-existence of carbocation. Next, I will take some various examples. This one, That is an allyl bromide. That is an allyl bromide. That is an allyl bromide. Okay. Done. If you can react with aqueous KOH, that means OH minus. This is another good example. This is a very big example. If you can take this one, then CH2 double bond CH and CH2 plus. And this is the allyl cation. Allyl cation. Stable carbocation. Allyl cation, there is a stable carbocation, there is a resonance stabilized carbocation. There is a resonance stabilized carbocation. So OH minus can attack and it will get CH2 double bond CH, CH2 OH. That is an allyl alcohol. That is preferable for SN1 mechanism. That is that part. Another one. That is neopentyl bromide. Important question. A plus B. That is neopentyl bromide. When A plus B, that means major and minor. That is the big part. That is the major and minor. I will give an example. In that case, that is a rearrangement reaction. I will give an example in that case. That is a rearrangement reaction. Rearrangement reaction. First, leaving group leave, that it will take CH3, 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 CH2 plus. That is carbocation. And that is primary carbocation, less stabilized carbocation. Then OH minus attack that part, it will produce CH3, 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 CH2, OH. That is the minor product. Due to formation of less stable carbocation. Then CH3, 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 CH2 plus. That is the migration or rearrangement. That is the migration or rearrangement or 1,2 shift. That is the migration or rearrangement or 1,2 shift. That is CH3, CH3 plus CH2, CH3. That is the 3-degree carbocation. That is the 3-degree carbocation. Most stable carbocation. Then OH minus can attack that part. So it will produce, that is a very big question, C, in that case CH3, in that case OH, in that case it will get CH2 and CH3. That is the alcohol. And that is the measure because there is an 3-degree carbocation. Do you agree? Next one, I will take benzyl bromide. I will take benzyl bromide reacts with aqueous KOH. Identify the product. Reacts with reactor leave this one, this OH minus attack, and this one, that is benzyl alcohol. That is benzyl carbocation. That is preferable for SN1 mechanism due to resonance stabilized SN1 mechanism due to resonance stabilized carbocation. Next, I will take another example. That is also another good example. CH3, CH, Br, CH, CH3 and CH3. Aqueous KOH, A plus B. When A plus B, that means major and minor. When A plus B, that means major and minor. It's leaving group, leave CH3, CH plus, CH, CH3 and CH3. That is 2-degree carbocation. That is 2-degree carbocation. That is then secondary carbocation. Secondary carbocation is also preferable for the SN1 mechanism. So OH minus attack at that part, it will take CH3, CH, OH, CH2, and H3. Agree? Yes or no? And that is the minor product due to less stable carbocation of 2 degree. Due to less stable carbocation of 2 degree. What is the major product? CH3, C, H plus CH3, CH3 and CH3. This H can migrate in that one. It will produce CH3, CH2, C plus, CH3 and CH3. And that is the 3 degree carbocation. That is the 3 degree carbocation. So, aqueous OH, that means OH minus, and this OH minus can attack in that way. It will produce CH3, CH2, C, OH and CH3 and CH3. Done? And that is the major product. Both are under the part, that is the major and that is the minor. Hear it? Another example in the rearrangement reaction. I will take another example in the rearrangement reaction. That is major and minor. That is major and minor. First, we are leaving that is main part, that is 2 degree carbocation, and OH minus which can attack. So this will produce CH3, CH3, CH, OH and CH. That is the minor product due to less stabilized carbocation 2 degree. That is the minor product due to less stabilized carbocation 2 degree. And one thing remember, major product which one? CH3, C plus, this is the CH3, this is the CH3, this is CH plus and CH3. Anyone which can shift or migrate 1, 2 shift or 1, 2 migrate. OH minus, it can attack this one. That is 3 degree alcohol. And that is major product. First one, and that is the 3 degree carbocation. First one is the minor, second one is the major. Done it? Then write down stereochemistry of the SN1 mechanism. Stereochemistry of the SN1 mechanism. Stereochemistry of the SN1 mechanism. I think 2 part. Retention of configuration. Retention of configuration, 2 part. That is the stereochemistry of the SN1 mechanism. That is the big part. Stereochemistry of the SN1 mechanism. One is retention of configuration, another is inversion of configuration. Inversion of configuration. There is the 2 parts. Retention means configuration can retain. Inversion means configuration can oppose it. One thing remember. That means that is R1, that is R3, that is R1, and that is R2. This carbon is chiral carbon or asymmetric carbon. Okay? You can attack, first of all, PR remove, and you can attack any nucleophile. Say whatever may be OH minus, whatever may be any type of nucleophile. First, you will get that carbocation. First, you will get that carbocation. R2, R3, R1, and there is a vacant one. Any nucleophile, I will take this nucleophile. This nucleophile attack, this is the positively charged, this nucleophile attack from this angle, that means top attack. Top attack. Top attack. And this nucleophile, which can attack at that part, That means bottom attack. When bottom attack, it will produce R2 R1 R3 and NU, ultimate product, and that is the inversion of configuration. When you can leave the BR, the nucleophile attack at the opposite one, that is the inversion of configuration. That is inversion of configuration. When you can attack the bottom side, then you can attack, that is an inversion of configuration. But when you can attack the top side, then ultimate product C NU R3 R3 R2 এটা হচ্ছে R1, and that is retention of configuration. There is two different parts. When in case of SN1 reaction, inversion of configuration can also occur, retention of configuration can also occur. When you can cleave the halide ion, the nucleophile attack and that side, that is the retention. Clear? Then I will discuss another part, and that is SN2 mechanism. That is SN2 mechanism. SN2 mechanism. SN2 mechanism. First of all, reactivity of alkyl halide. First of all, reactivity of one thing, remember, one thing is same. This one, Ri greater than Rbr greater than RCl greater than Rf. In these two are same for SN1 and SN2, but another for SN2, that is CH3X is methyl halide greater than CH3 CH2X greater than CH3 CH2 whole to CHX greater than CH3 whole 3 CX. That means 1 degree greater than 2 degree greater than 3 degree. That is just opposite of SN1 mechanism. Just opposite of SN1 mechanism, and this mechanism does not depends on any stability of carbocation. This mechanism does not depends on any stability of carbocation. This is the reverse one. in SN1 mechanism, in SN1 mechanism, then in that case 3 degree greater than 2 degree greater than 3 degree greater than 2 degree, 3 degree greater than 2 degree greater than 1 degree for SN1. But in case of SN2, 1 degree greater than 2 degree greater than 3 degree for SN2. Agree? Effect of solvent এখানে, this is the alkyl halide and this is the nucleophile. That is the one-step process. That is the one-step process. Living group and attachment of nucleophile, it can take place simultaneously. That is the one-step process. That is the one-step process. If we take this angle, deuterium, there is an X halide, nucleophile, living group. First one, this is the part, that is the transition state. That is the transition state. L minus X H and P. That is the transition state. That is the transition state. And ultimate, it will get a product that is CNU, that is an R, that is an H, that is an D, and X is the living group. That is the ultimate product, and that is the SN2. And that is the one-step reaction. That is the one-step reaction. That is the one-step reaction. dx by dt, dx by dt is directly proportional to concentration of alkyl halide and nucleophile both. So it will take dx by dt equal to k into concentration of alkyl halide and nucleophile both, and that is the second order chemical kinetics. That is the second order chemical kinetics. No rearrangement reaction, no stability of carbocation, no resonance stabilization for SN2 mechanism. For S dx by dt is directly proportional to both concentration of alkyl halide and OH minus. For this reason, this is the second order chemical kinetics. Next, I will discuss stereochemistry of the SN2 mechanism. Stereochemistry. When I have discussed for SN1 mechanism, then inversion of configuration and retention of configuration both have been done in SN1. But in SN2 mechanism, only inversion of configuration. That only inversion. How can you approach? This is that is leaving group X, that is H, that is T, and nucleophile. Leaving group leave and nucleophile attack an opposite side. Nucleophile attack at opposite side. So you can attack the nucleophile in that angle. So Nu C CH3 H and deuterium. That is the ultimate product. Leaving group X minus. That is leaving. So leaving group leave and nucleophile can attack at opposite. For this reason, this is called inversion of configuration. For in case of SN2 mechanism, that is inversion of configuration. This inversion is called Walden inversion. Walden inversion. That is the very big topics for SN2 mechanism. Done it?